Hello, ladies and gentlemen. So we're starting out in our chemical reaction unit, and today I want to show you two chemical reactions that one you're probably familiar with and the other you are not. And you're going to have a corresponding data sheet with this, and we will talk about that soon enough. But let me physically show you as best I can in this remote setting these chemical reactions. What I have here is a piece of magnesium metal, magnesium ribbon. I'm going to walk to the camera and show you the magnesium ribbon. It is a silvery gray piece of metal. It is very bendable, pliable. It can be shined up. It can be polished if I wanted to. And what's interesting about this particular metal is, again, pure magnesium, so the element Mg. If it's heated enough, you think of most metals, you heat it, they get hot, maybe you start to melt the metal. But with magnesium metal, it has a little interesting property that if you gotta have a hot enough flame, so I can't use a match, not that anybody uses matches anymore, I gotta use a lighter. But if I heat it enough, it burns. It burns a very, very hot white light. It burns in the presence of oxygen. And it combines with that oxygen and makes a compound, magnesium oxide. This magnesium oxide is a white substance. It's very, very brittle and can almost become a powder and an ash. And so the properties, again, of what we call reactants, the material before the chemical reaction, we call those reactants. The properties of the reactants in chemical reaction are generally very, very different than the what we call the products, what was produced during the chemical reaction. So in this case, we had magnesium. We burned it with the oxygen that existed in the air, and we made magnesium oxide. Again, in our data sheet, we're going to see how we write that, and we're going to explore that a little bit more. We also, of course, when we do chemical reactions, we need to explore what do the reactants look like beforehand and what do the products look like afterwards. And we identify the change that happened. And in this particular case, the change was quite dramatic because we had a very bright, white, hot light. Since we're talking about combustion, I'm going to show you another chemical reaction with something that you're probably familiar with, natural gas. Natural gas is methane, CH4. One carbon, 4 hydrogen bound together. It's one of the lightest petrochemicals that we use for fuel. If you have an electric stove or an electric hot water heater, you may not be as familiar with it, but you probably know enough about natural gas. Now, when I turn this on, the natural gas comes on. You can hear it. I can smell it, but you can't see it. It's a clear, colorless gas, and that clear, colorless gas is going to react with the oxygen in the air, again, which is a clear, colorless gas. So our reactants are going to be the methane and the oxygen. Now, when they do react, if we give them a little spark, well, it'll burn. And this specific kind of burning is called combustion. There's a difference between burning and combustion. We'll get into the nitty-gritty of that later. But what's going to be hard to tell is what are the products. Well, let's see the reaction and see what change happens, okay? So let's turn on the gas, turn on my lighter, and that's a reaction, that burning. It's throwing off a lot of heat, you see a lot of light, the chemical change is very evident. What's not evident is the products. So I'm just going to tell you what the products are. And you might be familiar with this from other background information, but when you burn fossil fuels, one of the things we worry about in today's society is carbon. They say carbon. How much carbon are we putting in the atmosphere? When we burn fossil fuels, we put out carbon dioxide. We breathe out carbon dioxide. Burning creates a lot more carbon dioxide. And that carbon dioxide, again, is a concern going up in the atmosphere and enhancing global warming. So that is one of your products. Now you can't see carbon dioxide because it is a clear, colorless gas and it's floating away. And there's already carbon dioxide in the atmosphere. That's what plants use to live. Another product that you can't really recognize here is water. Water is being produced right now. But the water is so hot, obviously, that you don't see it in liquid form. It's in gas or vapor form. And it is, again, in gas or vapor form, floating away, clear and colorless. We don't see it. Now, if we were to come by and try to chill some of this gas nearby, or if this were happening outside, we might see, kind of puffs of cloud, and that would be the water vapor condensing into little water droplets. So that's it. So, again, on the little data sheet, you're going to see this representation of this reaction in words. What we're going to do is we're going to translate it into symbols. We're going to talk about how we observe the reactants and the products in terms of their physical state and their color and other things and other nature. We're going to clearly indicate when the reaction is happening, what changes were occurring here. Obviously, a bright, hot, orange, blue flame. Well, really, the color would have been the blue flame. The orange happens a little afterwards. And there's more that we're going to have to add to these sheets and our discussion regarding chemical reactions as we move forward in the unit. This is only one of several sets of demonstrations that I plan to show you, since unfortunately we're not together physically. This is the best I can do, but hopefully it has enough meaning and create enough interest that that you can follow along, and that it what we talk about makes sense. Okay, so thank you for watching, and stay tuned for other reactions.